Hello all, welcome to 100bytes.com. This is Java concurrency series where in this last video we have seen about a Java reentrant lock. In this video we are going to see about the conditions of a Java concurrency package. The agenda of this video is like we will see what is condition, how it is implemented, and finally a demo. Before conditions, thread can wait on only one time per object, but with the condition we can have multiple wait sets per object. And by combining with an lock implementation, that is reentrant lock or some other your own lock implementation, we can achieve more complex use cases. It's directly mentioned like lock replaces synchronous methods and statements, where the condition replaces the use of object monitor methods. Each condition is intrinsically bound to a lock. That means like before waiting on a particular condition, you have to acquire the corresponding lock. After acquiring the lock, the thread can wait on a condition. When the thread starts waiting on a condition, it will releases the lock and suspends the current thread, so that the next thread will start the execution. Now we will see the wait function algorithm. This algorithm uses the W links in the queue fashion to track the waiting threads. Whenever a thread is start waiting, first it will create a node for the current thread and set the waiting status enqueued into the waiter queue. This is the locking stage and this is the condition stage. There are multiple threads which is coming here to acquire the lock and start waiting on a particular condition. So when a thread acquire the lock and it will start waiting in the condition, at that time the JVM will suspend this thread, okay, and it will unpark the successor. That means the another thread which is waiting to acquire the lock. So this guy will unlock this. This guy will acquire this lock and will start, and again it will go and start waiting on this condition and can keep on it's going for the next thread. That's what the third point. Like at the time when waiting in the condition, it will park that thread and it will wait for the signal or interrupt. And like whenever if a thread is when the thread is waiting on the condition, at that time if a thread is unparked, okay, there are two cases. It can be signaled or it can be interrupted. If it is a signaled, it has to again acquire the lock. Remember that this condition is inside the lock and unlock structure, unlock block. So it has to again acquire the lock, remove the predecessors from the queue. So that means like whoever it is released the lock, that will remove that predecessor thread from the queue and make this node make the current thread as a first in the queue and return it. Suppose if while at the waiting condition, if a thread is interrupted, it will remove the predecessor from the queue and make the node as first queue and throw the interrupted exception. Now signaling, the signal will signal the first waiter in the waited queue, and after that it will unpark the first waiter thread, so that it will start executing the next subsequent statements. And the class diagram is this condition object which implements the interface as it is mentioned, like it is a reentrant lock is using the condition object. We can't use the condition object without reentrant lock. And now the demo. Array blocking queue is like it's a JDK. JDK itself it's providing array blocking queue. What will do means like it has a array where if an array is empty, it has to wait. And if it is a full, it will signal. And the signal all demo, and the signal all, let's assume in a traffic signal where all the vehicles will wait for a green light. Once the green light is on, then that means like it's signaling all the vehicles in that signal, so all the vehicles will start moving on. Next is an EMI deduction. That means like every 30 days we will a particular amount will be deducted from a bank. So this wait condition can be used for this use case as well. Okay, now we will see the demo. I'm using a JDK 1.8 to execute all the classes. The first we will see the traffic signal problem. I have two classes, condition all, which is main class, and traffic signal. In the condition all, I'm spawning a 3 threads for each vehicles, and I'll wait for some time, and after that open a signal. In the traffic signal class, I have created one lock called traffic lock, and the traffic condition. The traffic condition is created on top of the traffic lock. Okay, So in the run method, all the threads will acquire the lock and wait for the particular wait for the traffic condition. Whenever open signal is called from the main method, it will acquire the traffic lock and will signal it will signal the traffic conditions. That means all the threads which are waiting on the traffic condition will be given signal. That's another flavor called a signal. Instead of signal all, if you give signal, then it will signal only the first thread which is waiting on the condition. Let's execute this. So you see here all the three vehicles are in the waiting for a signal for some time, and after that it started moving it. Okay, and the next is a condition wait. This is a EMI detection problem. So here also I have two classes, condition time and detection EMI. In the condition time, like I'm spawning a three threads for the three customers, and in the detect EMI class, I have a log called EMI log, and the condition is created on top of the EMI log. In run method, I'm using an await method. This await method comes in three flavors. Like one is await interruptly, await without time, and await with time. This await without a time is like it will wait for a particular condition. That means like thread will be in suspended state until it is signaled or interrupted. Await with time is like it will for the specified amount of time the thread will be in a suspended state, and before that the thread has to be signaled or interrupted. Await interruptly means like you can't interrupt it will come out only after signaling. I'm passing a 1 as a seconds, so that means like every second a money will be detected. Okay, so you can change it to 30 days by passing await 30 and this instead of seconds days. So that means for every 30 days the money will be start detecting. I'm reverting back to the same 1 seconds. Let's execute this code. So all the Chair and Cholan Pandian is waiting. After the waiting time, all the users money will got detected actually. This is infinite loop. I'm stopping it. Next I will explain how this condition is used in the array blocking queue. I will not going to run the I will not going to show the demo with this because in the next forthcoming videos I will have an example of this array blocking queue where I will show how the conditions are used. Now this array blocking queue has a, like you can see there's a log and it has a two conditions, not empty and not full, and this is created on top of the log, on top of the reentrant log. You can see that not empty not full is created. This is how the Java conditions will be used. We will see a running demo in the array blocking queue explanation video. The Java code I have shown in this video are posted on the 100 bytes page, which I given a link below this video. Please use that link to access this code. Thanks for watching this video. Visit 100bytes.com for more tutorials.